I think we are live right now. That's good. So, hello everyone again. So, we are very enjoying session right now from Shaun. So, he's going to present building games in .NET MAUI. And so, I hope you are going to enjoy the topic. And also, please feel free to ask your questions on the right side of the menu in Q&A section. And also in the chat, you can also feel free to share your also feedbacks. So, Shaun,
Thank you.
here you go.
Thank you. Hello, everybody. Thank you very much for joining me today. In this talk, all about breaking out of the typical scenario of building a business application in .NET MAUI and focusing on having some fun. In terms of format, I'm happy to answer questions, so please feel free to send them in and I'll try my best to answer. And on the topic of questions, I'd like to ask you all a couple of questions. Have any of you ever thought about what you had as a great game idea? Have you ever tried turning that idea into something that could be played? And then finally, have you ever started on that great idea only to be distracted by building something that you probably didn't need, but over-engineering the problem? If you answered yes to all three, then thank you. I'm not alone. And today's talk is going to be covering the journey of disappearing down the rabbit hole of trying to build a game engine. So let's get the introductions out of the way. My name is Shaun Lawrence. I'm an independent software engineer, Microsoft MVP, author of a book called Introducing .NET MAUI, and then I'm also an open source maintainer on the .NET MAUI Community Toolkit and a fairly new project called the Orbit Game Engine, which is the subject of today. But I guess the key detail is that last bullet point is the fact that I am an avid gamer. I still remember saving up to buy my first ever console back in '92, which was the NES. And I quite frankly just love how video games provide so many different things to many different people, whether it's an aid to learning through problem solving, or whether it's a virtual environment to escape when things become too much, or even a place just to hang out with friends when you're, say, stuck in the middle of a pandemic. And that was particularly valuable for us, certainly in the UK, when we went into lockdown and we were able to find an outlet for our children's social needs while we weren't necessarily allowed to leave and interact with others. You should also notice that my Twitter or X handle is on the bottom of any of these slides. So if there's anything I don't cover and we don't have time to answer any questions, please feel free to reach out either on Twitter or GitHub. It's the same username @Bidgington. But today I want to talk about a new game engine. I say new, it's been in the pipeline for a year or two, but it's most recently just come into a pre-release, and it's a 2D game engine that I've been trying to build on top of .NET MAUI graphics. While investigating MAUI the graphics APIs for my book, I discovered the sheer power of what can be achieved, and through the use of some past experience using Ski Sharp to build some other applications, I thought I'd embark upon the journey to see what could be accomplished out of the box with .NET MAUI. So that's with as few dependencies as possible. And in fact, the only two dependencies are .NET MAUI, it's .NET MAUI basically. That means that it doesn't actually bring in Ski Sharp. So while I initially assumed that was the case, graphics is its own API entirely, so it doesn't even need to bring in that. However, if you so desired, you can actually replace the graphics rendering layer with Ski Sharp. If we find that there's performance benefits for doing that, then that's a certain possibility. And then by the end of today's session, I'm hoping that you will have learned about two of my great passions, being .NET MAUI and, of course, gaming, and then what's going to happen when we combine the two of those together. Okay. Now, I must point out that there are a lot of options when it comes to building a video game. And if you want to pick a fully fledged game engine and build something out of, there's a fair number that are already available in the market. Some professionally developed as well. Some might cost money, but some also offer excellent community licenses, so free to start with. And so the game engine that I'm building, you're not going to go and build a AAA rated game, but hopefully it's going to provide enough of an API that you could get going and start to build something fun. And I guess one of the main reasons why I opted to embark upon building the game engine was actually more for the journey, maybe rather than the outcome. And I found that by choosing .NET MAUI, which is a framework that I'm fairly comfortable with, it allowed me to feel safe while exploring other concepts. So that seemed to be quite a pleasant experience while I'm scratching my head over complex physics. So on that note, let's take a brief look into what .NET MAUI is, and then we can work out how we can fit that in a game engine into that. I've aimed at keeping this part rather brief, but for anyone wanting to learn more about .NET MAUI, as I mentioned before, feel free to get in touch and I'll happily answer questions, help guide you through bits. But .NET MAUI in a nutshell it's a cross-platform framework designed for building modern applications. And that allows us to actually build them for running on multiple idioms. So we've got mobile being Android and iOS. Then there's desktop being Mac OS and Windows. Now the Mac OS part is done through the Mac Catalyst functionality provided by Apple, which is essentially running an iPad application on a Mac with some extra bits around it, so you can show the menu bar at the top and other bits that you can hook into the Mac ecosystem. And then there's also, if you so wish, there's the ability to run on smart fridges or smart TVs, and that's through the Tizen platform, which is provided by Samsung. So the top 4 on this bullet point list, or top 2, covering Android OS, Mac OS, and Windows, are all supported by Microsoft. The next one, Tizen, is supported by Samsung. So it's not first-party support from Microsoft, but it's Samsung is still a big company to consider a suitable piece of technology. And I did actually once, I still need to dig out a proper version of it, but I had a friend send me a video of one of my games, Orbit, a demo application running on a Samsung Tizen platform on a fridge, which is really quite cool. So .NET MAUI is the evolution for Xamarin Forms. So Xamarin Forms stopped in version 5, .NET MAUI introduced in 6. It came with a lot of breaking changes, but a lot of fancy features. So I now consider it a first-class citizen of the .NET ecosystem, meaning we get features such as the app builder pattern or the generic host builder pattern. Anyone that builds ASP.NET web applications should feel familiar to it. And actually, a lot of the, I believe, the intention of moving to this pattern then means it makes it a lot easier to transition between different .NET code bases, even across different frameworks and platforms, because it has a very similar bootstrapping process. And then there's the final point that I've labeled build with a platform. Now that might seem quite vague, but actually this is a rather key detail on the journey for building an engine, or at least a game. So while .NET MAUI isn't going to provide us a full, it does provide us a unified API, so we can add a button to the UI, to our UI, and it'll render it on each platform for us. It's not going to provide a full API surface that we need in order to build a game. Take interacting with a game controller, for example, such as this. That it's not going to be a widely requested feature, so it's not going to be something that Microsoft are going to want to provide and necessarily support. But that doesn't mean we can't do it, and it doesn't even mean we can't do it with relatively few lines of code. What we have the ability to is we can still interact with the platform-specific APIs provided by each of the vendors. So the Apple providing us the game kit for the game controller, Google providing us, I think it's Paddleboat, and then Microsoft, there's things like Xbox controller support, which is baked into Windows. So we can utilize that functionality while .NET MAUI doesn't provide it to us, we can still interact with those layers. So there is the .NET for iOS, the .NET for Android, yes, .NET for Windows or WinUI that allows us to get down to the platform layer and utilize that. And we can see an example of that coming up. Okay, so we've covered what .NET MAUI is and how, I guess, quite often it's typically suited towards business applications, but we're here to talk about games. So let's do that. Now, don't get me wrong, it is entirely possible to build games within a typical business application architecture. So I've built puzzle games using MVVM before, and we can still utilize some fancy features like particle effects to show off fancy animations. But things become rather complicated when we start to consider much more advanced types of games. When you consider multiple asteroids gravitating towards a planet, and we then need to deal with collision detection, among other things. And this is where we get into what is considered a typical game. But let me consider what I mean. So typical is basically a game that would be built on top of a game engine, and that ultimately provides us with the first real conceptual difference from building a business application. If anyone has built a real or worked on a real-time based system, so it's just like a SCADA application, this might feel fairly familiar. And so the difference is that rather than sitting idle waiting for user inputs like a typical business application would, a game will actually constantly loop. And so we have this looping pattern. And a game loop runs continuously during gameplay. Each turn of the loop is we're going to process user input, update the game state, and then render that state on screen. And then on the left, the engine will track the passage of time to control the rate of gameplay. But as a game developer, you don't actually need to know about the left-hand side. You only really care about the right. So your role as a developer is to understand how the player is interacting with your game, then how that affects the state of your game, and then how you're going to visualize that change in state or just the current state of things. And I should point out that we want to be really mindful of performance when building games. Well, obviously any application, but if you imagine if we were running at a frame rate of 25 frames per second, which might seem quite low now for modern PCs, then we would only really be allowed to take up to 40 milliseconds to do the 3 blocks on the right-hand side. Otherwise, we're then going to start to introduce lag, and ultimately the game's going to grind to a halt. So we've covered what a conceptual difference is between the application at a fairly high level, but there's 2 key components that I want to introduce before we then look at how we could utilize that to build a game. And these are, we've got a scene. So a scene, you could consider that a bit like a page in your application. It's effectively where you want the user to be at a point in time. So we can say that's a level, or it could be your home screen, your main screen. And then if you've got rather complex level setups, yeah, you could do it that way. And then an object. Now an object, as the name suggests, it really can be anything. Anything that really can represent some level of state in the game. And with this, I try to try and recommend that you implement some level of solid principles. So you can try to make sure that an object only really does a fairly small task and could be replaced if there needs be. So if you've got a shooter game where you've got a weapon that could be upgraded, then maybe you've got multiple different gun objects, and therefore you just replace the gun rather than having to deal with lots of complex switches in the code base. But both of these concepts fit into that engine, the loop that we mentioned, and provide you with the ability to update the state and render that state. So therefore, both of these, you could consider them to be stateful. Okay. So we've covered a bit of intro to .NET MAUI and some games, but let's look about how we can now use the Orbit engine to build a game. The QR code on the right-hand side, it takes you to the repository or up on GitHub. I believe the README on there should be up to date, and it should give a good overview of similar concepts that we're covering in the talk, and also how to get up and running. But if you do spot anything, obviously, please feel free to reach out or even submit a PR to correct it. This is being built entirely in the open, so it's feel free to contribute. So in order to initialize the library, we need to call I use Orbit Engine method that you see on the MAUI app builder. Hopefully this feels fairly familiar with anyone building a MAUI application, certainly because lots of libraries will have a use something that will then do some level of initialization. Now this doesn't do much, it just registers one class with the dependency injection layer, so you can then pull it in as a dependency because it's quite a key component. Right. So we mentioned before that the two key components, we have a scene and we have an object. But what we first need is we need to put a surface on the screen in our application to render the scene. So in order to do that, there is a class called game scene view, and as the name suggests, it's a view for representing a game scene. This actually provides you with a lot of interaction events, so you could deal with any touch-based events, multi-touch, and even hover events. If you're working on a desktop, obviously you can't detect if a finger's hovering over a smartphone. We're not quite there yet, but it gives you enough power there then to be able to deal with that, and then you could translate that. So that's one mechanism to be able to process the user input, and that's the touching or the interaction with the surface. And on the right, you'll see it's a blank application at the moment, but this is effectively what it renders to a application running dark mode. So we've got our surface to render to. Now we can actually create one of our first building blocks, or utilize the first building block, and that's a scene. In Orbit, it's called a game scene. And what we do is we can create our own scene, inherit from game scene, that provides us with a lot of the basic implementation, but there is an interface Sky game scene as well if you feel like you want to do things differently. Then what we're going to do is we create a scene. It's relatively simple. There is a purple tile, which is, you see, is repeated across here. It's a 2x2 tile, so it's a square at 64 by 64 pixels. To make this code fit into a slide, I've omitted the loop where that comment is, but we will look at that in an example in the example code base shortly. So the previous slide showed a preview of the scene. However, without loading the scene, that preview wouldn't be accurate. And there's a special part that glues the game scene and the game scene view together. And that's what that use Orbit Engine extension method does, is it registers the game scene manager that then can be pulled in through dependency injection or constructor injection. And that provides us with a load scene method. What this does is it will create you a new instance of your scene. This is home scene, that should actually say first scene. And it will then load it into the game scene view that you pass in as the parameter. I think it's worth mentioning that the load scene method works with scoping in terms of dependency injection. So if you just, hopefully this is the aim here, is to make it easier to manage state in the fact that if you decide you want one instance of maybe say your main character to exist through the life of the level, and then you can throw away state and then reload it in the next level load, then you can do that with load scene. So you'd register any instances or any types that you want with the add scoped extension method provided by .NET MAUI. And then that means you don't have to tidy up any state, which is really quite nice. And then our final item is to then render a game object. And a game object, as we mentioned, can represent any single object in your game. So I've got a couple of examples here just to make it, to show off what we can do. So in this first example, we're just actually going to represent a floor section. I think floor tile in the class name is probably poorly named. Floor section would be better, because then we could in theory even render floors in different places, and therefore make it that the user can move between and jump across. But the fact that there's an object there can become particularly important when we want to deal with things like gravity, and when a character falls, we could use certain tricks, like with things like collision detection, to make sure that we know there, and then we can stop moving, and then the character can carry on. The next example of the game object shows us rendering some collectibles. So this is in the form of floating cherries. For this, actually, we're going to make use of a sprite class. So that's provided by the framework again. You can just provide it with a set of images. It will put them in, and then you define how frequently to transition between each image, and whether it auto starts some life cycle parameters as well. And then if you add it as a child of your object, the base class will handle with the rendering. There's just a little bit of having to set where it exists at the moment. But this provides us with the ability to create some fairly simple animations through a set of images, a sequence of images. And I should add that all of these graphics have actually come from an artist online. I've got a link in a couple of slides' time to take you to it, and it's really quite fantastic, the level of detail that you get. So I'd thoroughly recommend checking it out, and I will show you the link at the end. And then we've got our main character called Pinkman. You can see maybe the background should have been a little bit more contrasting in the game. But what you can see is, in a similar vein to the cherries, we've got a sprite, we add it, and then there is a position there, which we'll cover in the example, rather than bloating this slide to the point where it wouldn't be legible. You will see how we can then control that character's position. So that showed how we can create some simple things and glue them together. But let's take a look at how they might become a little bit more complex in a demo application. So if we jump up here, you should be able to see we've got Rider running. So we'll just walk through those sequence of events quickly, and then we'll show this in action. So we initialize the library. We then register some other classes, although these are all created within this application. They're not coming from the library. And then I've just created some extension methods to allow us to register things within the namespace, just to make it a little bit easier to follow, and we don't bloat the size of the MAUI program. So this is almost matching what you get when you create a new .NET MAUI application. We had the MAUI, the main page, the XAML, which allows you to then, as we showed, we create the game scene view. This one is slightly more complex in the fact that we've added some buttons, rather crude at the moment, but they show that you can move left, move right. There's a little bit extra here, which will come into value when we actually run the application to show debug. It's just to allow us to show the bounding boxes when we're dealing with collision detection, because there's not a one size fits all for collision detection. So we can cover that topic shortly. And then there's a little jump button. You should see there's not much going on in here, but as I mentioned, there is the game scene manager that comes from the library. And then what we can do is we call load scene, and then we also call start. That's when the game actually starts running. And then just a little bit of extra bits to deal with moving the character around. We called load scene, which means a new instance of our first scene is going to be created. And you'll see that, again, there's yet more dependencies. You should also see I've tried to make it so that no scenes or objects are created to a point. There's a little bit here, but this could in theory be done with a bit of a factory method, so we can spawn cherries. So we've got our first scene. We add ourselves a character, a floor tile, and there's the setting service to deal with showing and hiding of bounding boxes. And then what we also do is we spawn 10 cherries that can be collected as we go along. The rendering shouldn't look too complex. We work out how many rows and columns there are, and then we draw the tiles across. So we're rendering them at 64 by 64 pixels. I think the image is actually 32 by 32, but it still looks relatively sharp, rendering it to this size. And we don't need to do any update. There's no state that we need to be maintaining in the first scene. Now, if you had a scroller, if you were allowing the player to scroll, maybe as they moved along, then we would need to potentially look at providing recording where the player is within the update, and then slowly scrolling the game across the scene across to show that to the user. So we've added the pink man and the cherries and the floor tile. The floor tile isn't much. That pretty much matches the slide that we saw. Cherries, again, there's not too complex. It's just there's a lot of images to load, but I'd like to find a way of simplifying this. Maybe if you have a folder and it just loads all of the images in there, as long as you can order them appropriately. And we give it a position, so then what that means is we can render it at a certain point, and we're translating. So the position is actually between 0 and 1, so that's between 0 and 100%, and then we're just putting it as a ratio based on the width of the canvas. So if the canvas was changed size, so if you've got a window that the user could change size to, then the cherries would move in respect to that size of the window, which is a valuable thing to do. Otherwise, you're going to end up with them all in one place rather than across. We also have this collide method. And what happens is, so when our character collides to collect the cherry, what it's going to do is the cherry will remove itself from the current scene, and then it's going to add a collected effect. And all this collected effect does is then it just runs another sprite animation, which makes it look like the cherry has been collected. We have a separate play mode type, which is single, which means actually it's not going to loop. So typically, by default, a sprite will continually loop. You can actually change it so it'll just play it once and then it'll stop. And there's that. And then also, once the sprite stops running, then we remove it from the scene to tidy up after ourselves, just to make sure that there's not leftover game objects. And then the pink man is actually a bit more complex than we showed in the slide, purely because there's a bit more going on. So what we've got is we've got the ability to, if I open character state, we've typically by default the character is idle, but he can move left or right and jump. So that's managed here. It kind of shows and hides the relevant sprite. And you'll see, actually, so the sprite rendering is managed for you, so you don't need to do that. The only thing is in the jump status at the moment, there is only one image, and therefore you need to render it. Although I guess you could technically have a sprite, it just will render one image on a loop. And then this is a rather crude approach of collision detection. And as I mentioned, there's not a one size fits all. This will actually just check to see, it'll put a square around the bounds of the cherry and a square around the bounds of the character. And then it will just find anything that intersect with each other. And then we'll detect that, and then we'll show that it's collided. So let's have a quick look at that application. Here we are. So as I mentioned, there are little buttons that let you move and jump. And then you'll see it does actually show at the moment that we are colliding sooner than we would expect. And this comes into some values to this bounding box or the show debug checkbox. The things it does is, I mean, these are manually being drawn at the moment, but it's drawing a rectangle around the bounds of the item itself, the object. So what we'll see is actually when these get close, that's when the collision happens. So this is rather crude, but this ultimately comes because the images are 64 by 64 pixels or 32 by 32, but they've got padding within the image to be able to make sure that things don't get cropped, certainly when you've got a sprite, because things move around. In theory, we could drop it so it could actually be a lot smaller. Or the other option is then to be able to define maybe an ellipse, which would be closer to the shape of your object, and therefore the collision will actually look much closer. This is an item that I'm currently working on. I do have elliptical collision working, but then the complex question comes of what if you've got a rectangle and an ellipsis, and how far do we go? So this is something to be working on. And the only other thing is this current view shows is the number of live objects in the game. So if you come along, you'll see, even though we collide, it stays at 9, and it's actually only when the collected effect disappears that you get 7. Okay. And the other possible option is you can show that it runs on a mobile device as well, because we are running cross-platform. You've got that there, and that's the same game. It's just running in light mode rather than dark mode, so you get a different background is all. Okay. And then the only other thing that I quickly rushed through before this talk is the concept of using a game controller, because I talk about processing user input. So I've got a PS4 controller here, and what you should be able to see is if I push left and I push right, now actually character can move and go and collect everything. There we go. So to have a quick look at that, because it is surprisingly little amount of code, and it gets to show how we can actually make use of .NET for iOS or .NET for iOS in order to be able to do that. So this typically, if you're going to end up implementing something like this, the documentation may not necessarily exist in the Microsoft space, but you're interacting with the game controller. So this is the game controller kit or framework that's provided by, it's game kit that's provided by Apple, and game controller is the namespace within that kit. And what we can do is we can use, these are their classes. Microsoft provide the bindings to them, but we can set up a notification to receive whenever a controller connects, something's connected. That will then fire our method. We'll find any controllers that it finds in the system. Now this is crude, it's taking the first or default, but you could have multiple. I've got a fake SNES controller here that works. I've got one of those little caddies for a phone that works as well. It works via Bluetooth, and that's how this the PS4 controller is connected. I don't have to set any of that up. That connects to the OS for us. And then what we are able to do is we can then interact with what's called the input profile. Now this is a physical controller, so we connect to the physical input controller physical input profile, sorry, and then we can subscribe to the changed event, so we can detect what the state of the buttons are. And also to initialize things, we have to kick off wireless controller discovery in order to make sure that we pick them up. And the controller can come in at any point, so it can connect in while the games are running, and you'll still be able to use it. It might be worth considering whether you want multiple control schemes based on if you want touch, or if you want explicit touch or explicit game controller, because obviously on a mobile device you might have to render the buttons on the screen, and if you've got a controller connected, that's just noise to the players, to the visuals that you're presenting to the player. So it'll be worth considering that. This doesn't do too much. It just says whether we're moving left or right. It does have up or down, but actually that's not a concept within the game yet. There's that. The other thing to point out is that with the Apple framework, they have the ability that if you don't have a controller connected, you can opt in for it to display a virtual controller for you. I forget exactly where it is. It's in the documentation somewhere. So yes, you can opt in to have a virtual controller displayed on the screen for you. So you don't necessarily even have to worry about rendering that for you. Okay. So let's carry on. So one of the next steps I would advocate for, and I wrote these slides before I decided I would actually implement that game controller support just to show off what's possible. So the next step I would have looked at is game controller support. Now I've shown you how you could do it on Mac and iOS. There is the paddleboat library that's provided and documented by Google, and then there's also Xbox controller kit for Windows, which you can also use. But when you consider what MAUI offers, it's enabling us to build applications that will render on, as I mentioned before, multiple idioms. So we've got desktop devices, we've got touchscreen devices, we've got smartphones and TVs. Smart fridges and smart TVs. So you end up with multiple different mechanisms of control, which is great, challenging and great at the same time. It opens up many different mechanics that we can introduce to our game. So obviously we can have touch and mouse interactions. We can have keyboard interactions if you've got a desktop, or even you connect a Bluetooth keyboard to your phone or your tablet. You've got the accelerometer in some of your devices, like your phone, so you could have a little marble run game that you make use of allow the player to tilt the device. You could even have the microphone enabled, so you can have some level of speech to text. And then so allow the user to talk to the game and invoke commands like that. And you could even consider that would actually make your game more accessible if people can't necessarily do it through any of the other means. And then there's also things like GPS. So if you wanted to be able to build some level of Pokemon Go clone, then you could do that. We've covered a bit. I'd like to leave you with a couple of tips and tricks now, just to aid you on the journey, because there's some pain points that I certainly learned that I think are certainly worth covering. One thing is the update method that you use really does need to be display independent, or make sure that you only update your state within update and not within render. One mistake I made initially was I decided I foolishly was updating some state in the render. So actually, if the player then decided to resize the screen, the render method gets called by the system anyway, which then actually means the state would change and therefore visual would change. Even if the game was paused and you moving that's a bad thing to do. So you want to keep those separate. And when I mention update, display independent and your state, if you imagine, for example, you built a drawing game that can run on multiple different devices, because again, that's what MAUI offers. If you're allowing someone to draw on a smartphone and the people on the other side are trying to guess what's been drawn, and actually, no, let's do it the other way around. If someone's drawing on a desktop machine and someone else has a smartphone, if you're doing it in absolute pixels, the person drawing on the desktop has a much wider canvas, and therefore actually some of the information might not even make it to the player's eyes on the smartphones. Now, if you make it all relative to the device it's running on, and then you translate that across to, so say if you wanted to draw something in the middle of a 1920 by 1080 screen, if you store that value as 0.5 by 0.5 rather than 960 by 540, then you'll be guaranteed that you can render it suitably on other devices. And I don't know about anyone else, but I get very frustrated with touch-based games. I mean, touch feedback on a slab of glass really doesn't offer much feedback. So I always like to introduce some level of haptics. As an example, in a word search game, we've added in the ability to give a little positive reinforcement that they were touching a letter, and then as they drag, then they know that they're touching the next item. So even if they can't visually see what they're dragging because their finger's on top of it, you give them the ability to feel that they are moving across, and then they know where they've got to. And then on the other side, you could also add in vibration support, but you have to consider that that is more of a negative feedback. A vibration is usually something's gone wrong, like an asteroid's hit the planet, rather than you've done something correctly. And you can even do a sequence of vibrations or haptics to then give like to mean different things. You can have a double haptic if they've guessed a word correctly. Audio makes a massive feedback. I know with apps that we've built in the past, we've actually added audio right at the end, and actually a lot of like beta testers have questioned or at least noticed the improvement that audio brings. And then just make sure that you do make full use of the tooling in the framework. So like I say, .NET MAUI now gives us the generic app post builder pattern and decent dependency injection support. So therefore, I would thoroughly advocate for using that, because it then allows us to potentially make things simpler and even testable. I always feel the need to bring up this topic. Accessibility is such an important topic. .NET MAUI is offering up ways to make it easier for us as developers to make our applications more inclusive. And with one crude benefit is that it has the ability to increase our potential user base for our applications. And if we're charging money for that application, that actually gives us the chance to make more money, or at least hand more money over to Apple and Google. And with it, we gain the ability to access things like the screen reader. So we could even, so when a level is loaded, or if a new boss comes in that we have to fight, we can actually announce this to the player. And then there's things like we can aid the screen reader, or the player. So if we want to render something on screen, and obviously this game engine makes things tricky because we're drawing things on a canvas. It's not something that the screen reader can interact with. So that's where the screen reader comes into play. But the beauty of being able to build a game within MAUI is that you can do this rendering, but then you can also, if you want to put a button on the screen, like you saw in the example, you could just add a button, and the screen reader knows how to report that to a user. And you consider if you've got something like you almost go back to the duck typing concept. If it looks like a button, quacks like a button, then it should be a button. Therefore, put the button on the screen. This is actually only scratching the surface of making applications and games more accessible. The useful section at the end in the blog post that I've referenced at the end of this talk does cover some more topics, so I would thoroughly recommend checking it out. So other examples of making things more accessible is we could provide a higher contrast ratio between background and content. So actually you saw the pink man, that was probably less accessible than it should have been. So we could improve that with maybe a green background. And then there's another thing, like, so if you imagine on iOS, people might turn on reduced motion, then maybe we should not actually do any form of animations. But that's sort of a user gets to opt into that. When I told my daughters that I was done to build games, they disappeared for an hour or two and came back with a PowerPoint presentation of what they'd like me to build. So at the moment, we are discussing between us how we're going to create this game, and actually this platformer style game that we've just demoed is providing some inspiration for the concept. I think it might either be a platformer based or an endless runner. So I watch this space. The repository, the .NET, the Orbit game engine repository up on GitHub actually ships with a couple of sample applications. So there's 2 Signal R based games, one to build a 2-player real-time air hockey game. The drawing game, I'm not sure it's 2 players, probably multiplayer. So one person can draw, multiple people can guess. Then there's Orbit, which is actually the original inspiration for this engine. And that is a bit of a crossover between asteroids and planetary defense. And then there's also Platformer, which is this simple platform game that we've discussed. There's 2 others in there as well, which actually were from previous talks. and they are games rendering the slides in themselves as well. So you can look into that as well. There are a couple of useful resources here that I would thoroughly recommend checking out. So as I mentioned, audio is a very big part of a game. While we're saying video game, audio does make up a big part. And then visuals. So if you struggle for inspiration, which I certainly do from time to time, at least I have an idea of what it was, but I can't necessarily translate that into paper or any form of digital form. Then these are great sites. So there's Open Game Art, and then there's itch.io, and the platformer game is from this link at the bottom here, this pixel adventure. So that's it. That's me. Thank you very much for coming along to the talk. This QR code takes you to a blog post, and that gives you links to useful resources, the repository, and other bits and pieces, as well as my details. But please feel free to reach out. Again, I'm on Twitter as @Bidgington, as well as GitHub, or find me on LinkedIn. So thank you.
Well, thanks again, Shaun, for this great presentation. So I would like to read a couple of questions
Yeah, sure.
in the Q&A section. So the question is, how does MAUI graphics renders on the screen by using OpenGL, DirectX, or SkySharp for each frame?
So as with MAUI, so you think MAUI is a unified API for rendering from, so the button will render as a UI button in iOS and Mac Catalyst. In a similar way, you've got the same level of platform-specific rendering with the MAUI graphics API. So we will say render an image, and that will then go delegate down to say the core graphics, which is the MAUI implementation, or sorry, the Apple implementation that MAUI uses to do the rendering there. And then there's Android graphics, and also then Windows or Microsoft graphics, depending on whether you're WinUI or WPF, which is quite exciting because things like core graphics are built to render on Apple devices. So it is, in theory, capable of handling something like hardware acceleration. I haven't got to levels of testing that fully, but it's certainly within the Apple documentation that core graphics will do that for us. And even levels of being able to cache parts of the canvas as well if it's not changing. So there's potential to then optimize things there. I hope that helps.
Okay, for the next one is, can mono runtime performance handle much more complex games? Does AOT compilation work better?
So I'm haven't worked out how complex the game can get yet. I've been building one of the other sample games is more complex than this. As I mentioned, it's a planet that's rotating around, and you've got a ship that has to defend it. There's a lot more mechanics involved in that, and I've not noticed any real level of performance issues. The bit that I want to get to is doing some level of benchmarking in terms of what the .NET MAUI offers us, and then also potentially to swap in Skier and see if we get better performance there. But obviously with Skier you bring in more dependencies, and therefore you make your app bigger, so might be a bit of a balancing act. And then I do fully suspect that things like AOT should only make things better. But that's a lot of support of that's coming in 9. So there's a preview out at the moment with something to play with.
Cool. Okay. So the other one is from me actually. That seems like there's an implementary point in collision detection, what I see. Because if the player faces an FPS problem temporarily, seems like the game Pinkman is go through the cherry itself because it's not going to catch the frame. So maybe might be an area to improve it, like continuous collision detection or something similar.
Yes, yeah. So the thought being is there might be some level of a separate thing that's responsible for collision detection rather than an object deciding whether it's collided with other people. And therefore you could do that outside of that loop. Yes, I think that would be very sensible.
As far as I see, the last question is, how about the input management controller and keyboard mappings?
Yep, so I did show that you can use controllers. Keyboard mappings is a little trickier. I think you could hook up a renderer to your current view, and then you can then receive the keyboard events.
Mhm.
There was a good post on it recently. If I yes, yeah. So with the handler architecture, you can basically you can subscribe, you can grab hold of the native view, the platform view. So if that's a UI view on Mac OS, then you can then subscribe to the key down and the key up events, and then you can map that across.
Okay, so that was the last question. And so I don't see any more questions. And Shaun, do you want to add something else as the last word?
No, just thank you everyone for coming
Sure.
along. It's been really great fun, and thank you for having me.
Thank you so much. So before stopping this session, I would like to remind people that at the end of the day, we are going to announce the raffle giveaways. I mean, the raffle results. So keep chasing them. So thanks, Shaun. See you next time then.
Thank you very much. Bye.